Some discoveries in astronomy arrive quietly, almost unnoticed, hidden within complex data sets and long nights of observation. But others come crashing through the calm surface of our understanding, like a meteor slashing through the darkness of the sky. This is one of those moments. The story we bring you tonight begins not in the cold silence of deep space, but in a control room in South Africa, where an array of enormous dishes, gleaming under the southern stars, caught something extraordinary. A whisper from the cosmic dark. A signal that should not exist. Yet it does. They called the object 3 Atlas. For months it drifted through the solar system, an interstellar visitor like so many before it. But this time, something was different. It wasn't just reflecting sunlight, it was responding. It wasn't simply a rock pulled by gravity. It was acting, releasing material in ways that defied the neat equations of cometary mechanics. Scientists were expecting dust, ice, inert matter frozen for eons. Instead, they found movement, pulse, breath. It is as if this object were alive, or something built to imitate life itself. The first signs were faint, almost ignorable. Subtle changes in its brightness, small shifts in trajectory, the kind of anomalies that could be easily brushed aside as errors of measurement or optical illusions. But then came the data from the Meerkat radio telescope, a machine so sensitive it can detect a whisper from across the galaxy. Amid the background hum of the cosmos, it found something no one expected. A structured absorption line, the spectral fingerprint of the hydroxyl radical, OH, an echo of water broken apart by solar radiation. In other words, the object was exhaling, releasing vapor into space. That discovery alone would have been remarkable, but the pattern of the signal told a deeper story. It wasn't random, it wasn't noise. The lines were too precise, too coherent, too intentional. The kind of structure you would expect not from chaos, but from design. And when scientists tried to fit it into their models, thermal emission, chemical outgassing, sublimation, they found themselves facing something that simply didn't fit. Some called it a fluke, others a calibration error. But one voice rose above the cautious murmur of the establishment. Avi Loeb, a man whose name by now had become almost mythic in modern astrophysics. Loeb had been here before, at the center of controversy, at the frontier where science meets the unknown. And once again, he dared to ask the question that so many feared to voice: what if this isn't natural? What if we are witnessing not the randomness of nature, but the intention of technology? At first, his words were met with predictable skepticism. After all, space is full of surprises, jets of gas, magnetic anomalies, cosmic coincidences that mimic purpose. But then, just as the debate seemed to settle, the images arrived. High-resolution frames showing 3 Atlas near perihelion when it swung closest to the Sun. And that was when everything changed. The photographs revealed not a simple cometary coma, but a structured branching network of jets, 7 distinct streams of material, perfectly separated, each angled in a way that defied expectation. 7. Clear, symmetrical, controlled. Was it possible that this object was maneuvering, adjusting its course as it passed through the solar wind? Loeb's team began to suspect so. And that suspicion began to spread, quietly, almost unwillingly, through research centers and observatories across the world. Something about this story carries an unease that words struggle to contain. The unease of being watched back by the cosmos. The realization that the unknown might not just drift, it might decide. Scientists tried to stay grounded, to avoid sensationalism. But even in the most cautious reports, the undertone was clear. The data did not behave like anything we had seen before. Still, there was silence from certain corners. The high-resolution images, rumored to have been captured by the Mars Reconnaissance Orbiter, remained locked away, unpublished, inaccessible. Requests were filed, official and personal alike. None returned with answers. The longer the wait continued, the deeper the unease grew. What were they seeing, those who had access to the original frames? Why was the world's scientific community being held back from viewing them? For now, we are left with fragments, a signal, a pattern of jets, a trajectory that refuses to obey the quiet pull of gravity alone. But the story is far from over. On the 16th of March, 2026, 3 Atlas will pass near Jupiter, close enough for the Juno spacecraft to listen. Its antenna, capable of detecting radio frequencies between 50 Hz and 40 MHz, may finally pierce the veil of the ionosphere and hear what Earth cannot. The hum of an engine, the rhythm of communication, the sound of something not from here. If Juno listens, and if we are willing to hear, what will it find? A frozen relic of interstellar chemistry, or a message sent not by accident, but by intention? The difference between those two answers could change everything we believe about life, intelligence, and the future of our species. And so, as we watch this object glide silently across the blackness, one truth remains: the universe has not finished surprising us. 3 Atlas is coming closer, and with it, perhaps, the first real whisper of another mind. Next, the moment the Meerkat Observatory confirmed the first absorption signature, the global network of radio astronomers awakened with the kind of urgency that only accompanies history-making events. What they had captured was not an ordinary background noise, nor a random burst of cosmic interference. It was a clean, structured signal, an unmistakable pattern that spoke of physical processes at play near an object thought to be dormant. The frequency range aligned perfectly with the hydroxyl radical, OH, a fragment of water molecules broken apart by ultraviolet sunlight. In astronomy, that molecule is a powerful diagnostic tool. It tells us about energy, about heat, about the intimate dialogue between a body and the star that illuminates it. To detect OH near an interstellar visitor is to prove it is not inert. It is to prove it breathes. Yet what made this signal extraordinary was its precision. The spectral lines did not blur as they should have if the emission were diffuse, chaotic, or turbulent. Instead, they appeared narrow, deliberate, coherent, like a pattern written upon the universe with the steady hand of physics, or perhaps the intention of design. When Loeb and his colleagues analyzed the Doppler shift of those lines, they realized something even more unsettling. The shift corresponded exactly to the velocity vector of the object as it moved relative to Earth. This was not a coincidental alignment. The absorption was occurring at the precise frequencies predicted for an active body undergoing thermal exchange with solar radiation. The data was internally consistent, elegant even. The width of the spectral features matched the temperature expected from an object at its recorded distance from the Sun. That meant that the process was genuine, not an observational artifact. The hydroxyl radical was there, real, cold, and moving in unison with 3 Atlas. The implications rippled through the community like an undercurrent of both awe and disbelief. A rock from another system, perhaps another star, was releasing the chemical fragments of water. For all intents and purposes, it was active. And then came the images. They were painstakingly assembled from multiple exposures taken on the 8th of November, through a combination of green, red, and blue filters. Each frame was calibrated for lunar interference, corrected for twilight gradients, and carefully stacked to maximize resolution. What emerged from the composite was beyond anything expected. The coma of the object was not a simple diffuse haze. It was structured, layered, almost architectural. 7 bright jets extended outward from the core, fanning into the void in complex geometries. Their directions were not random. Some leaned toward the sun, others, astonishingly, angled toward the background stars. Such behavior defies the basic principles of cometary sublimation, which dictates that jets should always point roughly away from the solar heat source. To many, this was the point where wonder tipped into suspicion. If those jets were indeed natural, they implied an improbably intricate distribution of volatile pockets, ice trapped in precisely oriented cavities across the surface. But if they were not natural, then they represented something vastly different: thrust, propulsion, controlled outflow designed to steer or stabilize the object in space. 7 exhausts, perfectly spaced, balanced like the attitude thrusters of a probe. The idea was breathtaking and terrifying. Avi Loeb, cautious yet unflinching, proposed that both explanations must remain on the table. On one side stood the conventional model, a comet-like body with asymmetric outgassing from localized icy regions. On the other, the radical hypothesis that 3 Atlas was not a natural fragment, but an artifact, a probe under power. He emphasized the need for open data, for transparency, for the immediate release of all high-resolution imagery. But the agencies holding those images, the teams operating the Mars Reconnaissance Orbiter, remained silent. It was known that the orbiter's high-resolution camera, capable of resolving features as small as 30 kilometers per pixel from interplanetary distances, had captured multiple frames of the object on the 23rd of October, 2025. Yet none of these images had been made public. In the absence of new data, speculation thrived. Scientists debated every possibility: a rotating nucleus with uneven albedo, a binary core ejecting material from twin vents, even the rare phenomenon of antitails, dust structures appearing to point toward the sun due to orbital projection. But as the analyses deepened, another anomaly surfaced. The object's trajectory did not align perfectly with gravitational predictions. It was drifting subtly, steadily, off course. The calculated deviation demanded the introduction of a non-gravitational acceleration into the orbital models, the same type once invoked to explain the behavior of the interstellar object Oumuamua. To produce such an acceleration naturally, a comet would need to lose an enormous fraction of its mass through gas jets, enough to visibly cloak itself in a massive glowing cloud. But 3 Atlas showed no such envelope. Its tail remained faint, its halo thin and compact. Calculations indicated that to achieve the recorded deviation, it would have had to shed roughly 1/15 of its total mass, billions of tons of material. And yet, no corresponding debris was seen by any of the 200 observatories tracking it. The contradiction was stunning. There was thrust, but no exhaust. At this juncture, Loeb introduced the concept of a technological hypothesis, not as an answer, but as a framework for scientific humility. He argued that when an observation resists all known physical explanations, it is not unscientific to consider artificial ones. It is, in fact, the most honest course of inquiry. His tone was not conspiratorial, but empirical. Collect more data, compare models, verify independently, and let the evidence speak. What he demanded above all was access, the release of the high-resolution orbital imagery and the raw radio spectra. And in doing so, he confronted a wall of bureaucratic inertia that seemed to him and many others inexplicable. Weeks passed, and still, the high-resolution images did not surface. According to internal estimates, those pictures could offer clarity at a scale no telescope on Earth could match, 10 times sharper than even the Hubble Space Telescope. They might reveal surface texture, shadowing, heat emission gradients. They could confirm whether those 7 jets emerged from chaotic cracks or from symmetrical, engineered apertures. The longer they remained hidden, the more the tension in the scientific community grew. Was the delay procedural or deliberate? Meanwhile, interferometric data refined the record of 3 Atlas's acceleration. The numbers refused to quiet themselves. The deviation persisted, consistent and directional, changing with the object's proximity to the sun but not in proportion to its luminosity. It was as though some internal control mechanism adjusted its force dynamically. The term non-gravitational no longer felt adequate. It was purposeful motion. A deeper layer of intrigue came from its trajectory through space. Its inbound path, traced back beyond the plane of the ecliptic, pointed within 9 degrees of the legendary WOW signal detected in 1977, a mysterious radio burst that had never been conclusively explained. The coincidence set imaginations alight. Could this be the same direction, the same origin, the same distant system reaching us again after nearly half a century? Loeb cautioned against romantic conclusions, but the alignment was statistically notable. Nature is vast, but coincidences of this magnitude often hint at something more than randomness. As radio observatories across the globe reoriented their dishes toward the coordinates of 3 Atlas, a pattern began to emerge. The faint absorption features persisted, consistent with hydroxyl molecules at low excitation temperatures, indicating ongoing release of water fragments. Yet beneath the noise floor, some analysts claimed to detect microstructures, thin, narrow-band features that hinted at possible coherence. These would be the holy grail of technosignature research, not natural emission lines broadened by turbulence, but engineered frequencies shaped by modulation. Though no definitive detection was declared, the possibility electrified the SETI community. For the first time in decades, the idea of listening, truly listening, felt urgent again. Loeb's proposal to use NASA's Juno spacecraft was born from this urgency. Juno, orbiting Jupiter since 2016, carries a dipole antenna capable of monitoring extremely low-frequency radio waves, frequencies that cannot reach Earth due to the shielding of our ionosphere. Between 50 Hz and 40 MHz lies a domain of sound the planet itself cannot hear. There, hidden from terrestrial interference, may lie the hum of plasma engines, the whisper of control signals, or the heartbeat of a machine crossing the void. When 3 Atlas passes Jupiter in March of 2026, Juno will be in a near-perfect position to observe. The plan is deceptively simple. Direct Juno's receiver toward the predicted trajectory and record continuously as the object passes within 53 million kilometers. If any narrowband coherent transmission exists, whether in the form of steady tones, pulses, or frequency drifts, it could be captured. The resulting data would either silence the technological hypothesis forever or ignite the greatest scientific revolution since the Copernican shift. In preparation for that encounter, over 200 observatories have begun coordinated monitoring campaigns. They track the object's brightness, its thermal flux, its photometric anomalies. Many report rapid variations, sudden blue shifts, and oscillations in reflectivity, all signs of complex, possibly rotational behavior. But the pattern does not match that of an ordinary tumbling comet. It behaves more like a stabilized platform, its apparent rotation damped, its jets firing in subtle rhythmic bursts. The collective weight of the evidence remains ambiguous, but profound. Each observation deepens the mystery instead of resolving it. Every test designed to confirm a simple explanation instead reveals new layers of inconsistency. For some scientists, this is exhilarating, the very definition of discovery. For others, it is unsettling, even threatening. If 3 Atlas truly exhibits artificial properties, then humanity is not alone in its ability to shape matter and control motion among the stars. And if it does not, if it is merely a natural object behaving in ways we do not yet understand, then our models of physics are incomplete. Either outcome reshapes the foundations of modern astronomy. Loeb himself describes the object as a mirror held up to our assumptions. Whether it reflects our technological hopes or our scientific ignorance remains to be seen. But one thing is undeniable. The universe, once again, has spoken. And this time, its language is both familiar and profoundly alien. A signal in the silence, a pattern in the noise, a question echoing through the void. What is 3 Atlas, and why does it move as if it knows we are watching? As March of 2026 approaches, all eyes, all instruments, and perhaps all hearts turn toward that approaching fragment of another world. What began as a routine observation of a faint interstellar object has become a threshold moment for human science, somewhere between natural and artificial, between chaos and design. 3 Atlas drifts and waits. To understand why the discovery of 3 Atlas has struck such a resonant chord in the scientific world, one must look beyond the data and into the long story of human curiosity itself. Every generation has faced its own frontier, its own impossible question. For ours, it is the question of whether we are alone. And if the faint, structured whisper from 3 Atlas is indeed the first breath of another intelligence, then history will record this moment as the dawn of an entirely new era of cosmic awareness. But even if the object proves natural, its very strangeness will have forced humanity to widen its vision, to stretch the boundaries of what we consider possible. The object itself has an intricate history that now feels like myth in motion. It was first catalogued as a faint, fast-moving point of light crossing the outer solar system, a speck sliding silently through the constellations. The designation 3I Atlas came from the telescope that detected it, part of the Asteroid Terrestrial Impact Last Alert System, whose acronym, ATLAS, now carries a poetic irony. What was meant as a watchman for dangerous rocks turned out to reveal something that challenges the very definition of a rock, and perhaps of life itself. Its trajectory was unmistakably hyperbolic, meaning it did not originate from our solar system. It came from elsewhere, from the gulf between the stars. By the time it neared the inner system, it had already begun to intrigue observers. Its brightness fluctuated in sharp, unexpected intervals, as if responding to pulses of sunlight or internal mechanisms beneath its crust. The early models that attempted to describe its spin failed repeatedly, each yielding inconsistencies in angular momentum and albedo distribution. No simple rotation could explain its shifting luminosity. When scientists later traced its path, they found something even more curious. It had entered from a direction near the constellation Sagittarius, close to the same sky sector that had hosted the mysterious WOW signal almost 50 years earlier. The symmetry of coincidence was haunting. As the debate swirled, the figure of Avi Loeb became a focal point, not just for his theories, but for his defiance of orthodoxy. Loeb, a Harvard astrophysicist known for his willingness to question convention, had long advocated for what he called the technological hypothesis. To him, dismissing the possibility of extraterrestrial design without examination was as unscientific as asserting it without evidence. His critics accused him of courting attention. His supporters saw in him the courage to face the unknown. But whatever one's opinion, no one could deny his persistence. When others hesitated to ask the forbidden question, he demanded that it be asked loudly and with rigor. Loeb's journey to this moment had been one of decades spent listening to silence. He had studied the faintest glows of the early universe, the first light after the cosmic dawn. He had helped to shape the search for exoplanets, the hunt for black holes, the theory of cosmic inflation. Yet nothing in his distinguished career compared to the weight of what 3 Atlas represented. For him, this object was not just a mystery, it was a mirror reflecting humanity's readiness to face the truth about its place in the universe. He spoke not with fanaticism, but with the calm urgency of a scientist who senses that history may be unfolding just beyond the reach of our certainty. Around him, a growing network of observers and researchers began to form, drawn together by equal parts skepticism and wonder. Amateur astronomers contributed raw images from backyard observatories. Data scientists developed new algorithms to parse the radio spectra for non-random structures. Space agencies debated whether Juno's instruments could be reprogrammed to dedicate more time to low-frequency scanning during the flyby. Even private foundations began offering funding for coordinated monitoring, realizing that this single encounter could become the most consequential observation of the century. But the object itself remained aloof, indifferent to the human frenzy it inspired. It drifted through space, its pale coma glowing faintly in the reflected sunlight, trailing 7 intricate jets like threads of woven glass. Some nights, telescopes captured subtle changes in their orientation, as if the object were reconfiguring its geometry. The angles between the jets shifted minutely over time, a dance too measured to be random, yet too subtle to decode. The question that haunted every observer was the same. Was this motion mechanical or natural, deliberate or incidental? The longer scientists studied it, the more 3 Atlas seemed to inhabit the threshold between definitions. Its surface temperature matched predictions for volatile sublimation, yet the distribution of its emissions was inconsistent with that process. Its brightness increased near perihelion, but not smoothly. It flared in sudden, almost rhythmic pulses. It emitted hydroxyl absorption lines, but the spacing of those lines showed slight harmonic relationships, as if following an internal resonance. To call it a comet felt insufficient. To call it a craft felt premature. So the world settled uneasily on the word object, as if language itself hesitated to commit. There was something profoundly humbling in that hesitation. For centuries, humanity has used its telescopes as windows of dominance, tools to measure, categorize, and explain. But 3 Atlas resists explanation. It stands at the crossroads of science and imagination, reminding us that the universe is not obliged to conform to our expectations. It reminds us, too, that the act of looking outward is also an act of introspection. When we peer into the dark, we inevitably confront the outlines of our own limitations, our fears, and our hopes. The upcoming encounter with Jupiter promises to be a crucible for those hopes. As the object approaches, the Juno spacecraft will orient its long dipole antenna toward the void, tuning itself to frequencies Earth has never truly heard. It will listen for the deep tremor of plasma discharges, for the faint echo of chemical engines, for patterns that might suggest intention. If the antenna hears nothing, the silence will still be monumental. It will confirm that nature can craft wonders that mimic design. But if it hears something, anything coherent, rhythmic, or modulated, humanity will awaken to a reality that no mythology or doctrine has prepared us for. The significance of that moment transcends science. It touches on the philosophical, even the spiritual. For if 3 Atlas is natural, it expands our understanding of the possible processes that shape matter and motion across interstellar space. But if it is artificial, then every discipline, physics, biology, philosophy, theology, will have to rebuild its foundations. The night sky will no longer be a backdrop for wonder. It will become a stage of communication, perhaps even kinship. Yet even as anticipation builds, a quieter, more reflective tone pervades the astronomical community. Scientists who once viewed the cosmos as an indifferent mechanism now speak of it with something approaching reverence. They realize that every discovery, no matter how alien, is also a discovery about ourselves. The human mind, reaching through darkness, searching for meaning, is itself a phenomenon of the universe, an echo of the same cosmic laws that may have given rise to 3 Atlas. In that sense, the search for other intelligences is not a search for the foreign, but for the familiar, refracted through the infinite distances of space. The technological hypothesis, bold and unsettling, remains unproven, but it has already served its purpose. It has reignited curiosity, reawakened the public imagination, and reminded science of its most sacred principle, to follow evidence wherever it leads, without fear. Loeb's insistence on transparency has inspired a new generation of researchers who view open data not as a privilege, but as a moral duty. They see in this controversy not a scandal, but a renaissance. a return to the fearless exploration that once defined astronomy's golden age. And beyond the laboratories and observatories, something deeper is happening. Across the world, people look up at the night sky with a sense of shared uncertainty. They wonder what 3 Atlas truly is: a messenger, a relic, a mirror. They imagine civilizations older than ours, shaped by physics, yet guided by intentions we can scarcely imagine. They wonder whether, on some distant world, another being once did the same, looked up, saw a faint light crossing their sky, and whispered, "We are not alone." When history looks back on this chapter, it may not judge it by whether the object proved artificial or natural. It will judge it by how we responded, whether we met the unknown with fear or with curiosity, whether we chose secrecy or openness.